More than 2 million people in the Netherlands wear dentures. Over time, these can become painful because the jaw bones deteriorate. When that happens, dental implants are the solution. In recent years, Radboud UMC has extensively researched how to improve the manufacturing of implant-supported snap-on dentures. A full digital workflow has been developed for this purpose. If a patient has an issue, the first step is to assess whether there is enough jawbone present. If not, the patient is referred to the oral and maxillofacial surgeon to supplement the bone deficiency so that implants can be placed afterwards. Once the implants have settled, a new digital 3D technique can be used to create these snap-on dentures. After the digital design and manufacturing process has been explained and the patient has opted for the new method, the first of just 3 clinical sessions is scheduled. During the first session, the focus is on collecting all the required data, with the facial image acting as the first calibration point. The Smile Design program is used to edit the 2-dimensional facial image. The dentist and the patient will determine the specifications for the snap-on dentures together. The app allows adjustments to the shape, position and colour of the teeth. The patient goes home with the Smile Design app to review the results and compare the digital design with their old dentures. Next, the markers are screwed onto the implants, and a 3-dimensional scan of the implants is made in the mouth. This creates a digital image of the implant positions. The following step is to scan the old upper and lower dentures, each one separately and both in occlusion. These scans form the basis for the snap-on denture design. In the laboratory, the collected data is loaded into a design program. By combining all the data, a personal 3-dimensional model is created that includes the jaw, the scan markers, and thus the implant positions and the old dentures. The titanium bar is designed with the old dentures as a guideline. The synthetic connection between the bar and the dentures, the so-called snap-on part, is designed on top of this. This element is eventually fixed into the prosthesis. Next, the teeth are designed according to the patient's preferences. They can be individually adjusted, moved, and resized. Once the digital design is finalized, the individual parts are milled. The digital design is used to print trial dentures in the color of the future teeth. The snap-on part, milled from wear-resistant polyether ether ketone, also called PEEK, is first fitted onto the titanium bar. This element is then glued into the trial dentures. During the second clinical session, the bar is fixed to the implants, and the trial dentures are placed on top. The dentist can now see whether further adjustments are needed. The dentist also checks the median line, the dental show, and the central occlusion. If adjustments are required, these can be made directly to the trial dentures. If needed, the occlusion can be corrected with bite registration material, such as futar. In the laboratory, a new scan is made of the trial prosthesis with the adapted occlusion. This forms the highly accurate digital base for the final snap-on dentures. The final snap-on dentures can now be created. The pink base and teeth are milled separately from blocks of wear-resistant resin. After this, the parts are merged. First, the PEEK element is glued in the pink basis. Next, the ring of teeth is fixed onto it. The technician also tests how the teeth and molars fit together, the so-called occlusion. The next step is assessing the lateral movements of the snap-on dentures. Compared to the old dentures, the new snap-on dentures have a much shorter base than the conventional ones. During the third and final clinical session, the bar is fixed in place, and the implant-supported snap-on dentures are extensively tested for fit, comfort, aesthetics, and the patient's specific needs.